thank the USRC for asking me to give this presentation. I was involved in the CNONC EBC committee maybe started around 6 years ago. So I wasn't quite there in the inception of trying to develop the system to be able to rate buildings. I was there right around the time when the committee decided to try to pick some existing methodology like ASC 31 to be able to kind of vet and test a general methodology. And so that's why I was asked to come in, because I helped quite a bit on the kind of going through ASC 31 and developing this process. So to start, if you were to open up your USRC manual, you can go to Appendix C, Chapter 3, and it talks about a technical review. And here it kind of gives you the basic requirements that are necessary for the technical review. Then you see here's the first time where it mentions an ASC 31 evaluation. So when you're doing the rating, you need to provide photographs, review all the Tier 1, or supply all the Tier 1 checklist items. The USRC does allow engineering judgment. Also, ASC 31 does allow engineering judgment. So if you just had a Tier 1 checklist and a few of the items would have been non-compliant for the quick stress checks, doing a more higher-end analysis, going to Tier 2, you could show that these previously non-compliant items are actually compliant. So the USRC wants to see that process of kind of verifying that Tier 1 non-compliance were deemed to be acceptable. And then finally, like I said, is providing that list of all items from the Tier 1 that had been switched over to be compliant. So that was Appendix C, and then we go to Appendix D. This is what Ron was saying has just been reissued to include all the tables. And this goes into discussing how the USRC uses the EPRS, which is the Earthquake Performance Rating System developed by CNONC. And I'll go into more of this later, but that kind of shows you where do you find this information in the USRC manual. So now we're really going to dig into Appendix D, because this is where all the EPRS information is located. So, like I said, the CNONC's Building Rating Subcommittee developed the Earthquake Performance Rating System. And just as a little background info, Appendix A within this document gives a lot of the background of what Doug was just discussing. Why did the EPRS develop in a certain way? Why were certain ground motions assumed? What was the focus of it? What is the intention of this earthquake performance rating system? That's all within the Appendix A document. So if you're looking for more background, kind of understanding why the ASC 31 translation leans a certain way, this is a good place to start. And then finally, we really get into the meat of this whole discussion, which is the actual ASC 31 translation procedure. So you have these two documents. The ASC 31 translation procedure is based off of the document on your left, which is the Earthquake Performance Rating System. So it builds off of that. In reality, you see that those two dates, the Earthquake Performance Rating System was issued February 2nd, and the ASC translation was March 22nd. In reality, they're really kind of developed simultaneously, even though the one comes from the other. Okay, so now we're digging into the CNONC EPRS. It's based on the ASC 31 standard. Currently, it has not been issued for ASC 41, so that's why I kind of put an X through there. So everything is based on the older standard up until the new update comes through. Another big thing is whether or not the building that you're evaluating is eligible to be used per the EPRS. So that's part one in the EPRS. Goes through this process. Have you done a site visit? Did you do an investigation? Have you modified properties based on condition assessments? If you answer yes to all these, then you are able to continue using the ASC 31 translation. If not, you need to use another procedure. Fortunately, by virtue of this part one, it's already been satisfied from the Chapter 3 requirements for the technical review. So if you're using the USRC methodology, you've already satisfied part one here. So I'm going to go over not a very detailed example, but kind of a quick example building. I'll call it example building 1. We're going to use this. It's a steel moment frame building with stiff diaphragms. That's the ASC 31 building type. It's non-benchmarked. It's a commercial office space. It's 12 stories tall, kind of mid-rise. We're fortunate to have an ASC 31 Tier 1 report. They did a site visit, visual inspection, condition assessment, so we've satisfied that that Part 1 from the EPRS. We're all very fortunate to have a complete structural, non-structural, and geologic site hazards / foundation checklist. That's probably going to be pretty rare. It's a big effort to have gone through all those checklists, but we're saying, you know, since we're fortunate to give an example, we're going to say you actually have all the information. And specific to the the structural checklist, all life-safe items are compliant. And then we do have, to simplify it, we have a couple non-compliant items. For the geologic site hazard, we have a non-compliant overturning item, and for the non-structural, we have stair details are non-compliant. So we'll go into what does it mean since those are non-compliant. What are the implications of that in our rating? So overarching, Doug went through all this. The rating is composed of 3 separate categories. The EPRS is safety, repair cost, and recovery. And you can get up to 5 stars in each of those categories. So now we'll jump into safety specifically. Just to reiterate, 5 stars means no entrapment, 4 no injuries, no death, so on and so forth. When we're looking at some of the tables later, it's good to just kind of remember what does the star rating imply about the building performance, because that's really how we ended up kind of grading or indicating what checklist items are required in order to satisfy 2-star or 3-star buildings. So now this safety rating is really composed of 3 individual sub-ratings. You have the structural sub-rating, geologic site hazard and foundation sub-rating, and a non-structural sub-rating. So each of those has a corresponding checklist in ASC 31. So we'll step through each of those sub-ratings, and we'll start off with the structural. And you'll take the least, the minimal rating from the 2.1, 2.2, and 2.3, and that gives you your overall safety rating that you'll report later. All right, so now getting into the structural safety sub-rating, going back to the ASC 31 translation, you'll check your building per section 2.1. Like I said, benchmarking is permitted. So if you go into ASC 31 Table 3.1 and you satisfy the life safety requirements, you can kind of stop there. You know you have a 4-star building for the safety sub-rating. If you manage to, if the design was for immediate occupancy, you could actually show that you have a 5-star safety sub-rating. So that's not the overall structural or safety rating. Remember, it's just the structural sub-rating, safety sub-rating. Another little thing to remember is if you have buildings with more than one building or seismic force resisting system, you need to do this evaluation for each of those systems. So let's say you have a moment frame in the longitudinal direction and brace frame in the transverse direction. You'll need to go through this procedure twice. And the overall ratings are based on the lowest of the moment frame or the brace frame building systems. And you'll see later on that all the 3-star and 4-star checklists from what the building rating subcommittee developed, they're exactly the same. And the reason for that is that really the scope of ASC 31 doesn't really properly differentiate between 3-star and 4-star, kind of when you're thinking about the structural performance. That's really more dictated by the non-structural performance. So kind of for bookkeeping purposes, 3-star and 4-star were exactly the same in the checklists. Okay, so how do we develop these checklists? I'm going to go into all this information, because if you look in the Appendix D, there's a lot of tables. You may be wondering how did the committee come up with it? We started out with the first pass of anything in the Tier 1 checklist that was a life-safe item. We started out saying that that item was required to get at least a 3-star rating for your building. And we did the same thing for anything that was an IO type of a checklist item. We said that you need that to at least get a 5-star rating. And then we applied a little bit of a committee judgment to revise particular life-safe checklist items that we thought had more to do with that could potentially be a global collapse hazard or a local collapse hazard. And so if we thought either of those would be a local or global collapse, we would modify that to be from a 3-star to a 2-star. Another little tip to understand is that the highest rating for a safety subrating is 4 stars for flexible building types. This has to do with the fact that the drift requirements aren't stringent enough to really say that you're not going to get entrapment within the building, which is what a 5-star rating implies. All right, so here's our building, or example building number 1. I didn't fill out all the circle, all the compliance, but all these items are compliant. Same thing here in the supplemental checklist. We have everything that's compliant. So now we can enter into the table 2.1 that's shown in Appendix D of the USRC implementation manual. And I'll go into how do you determine whether or not you have a 5-star, 4-star, 3-star, 2-star, 1-star type building. So we'll start off with the 1 stars. So what does it mean to have a 1-star type building? You would go into the checklist that I showed previously and look to see whether or not, say for the load path, is that load path item in your checklist compliant? If it is, okay, you would follow that through for now weak story, soft story, geometry, so on and so forth. So any item that has a C next to it, you need that in order to demonstrate that it is at least a 2-star safety subrating. So let's say for a different example, I'll start here. These are primarily the primary seismic force resisting checklist items. There were a couple exceptions for wood. Wood generally tends to be not a severe behavior. Anything that has to do with fundamental load path, that is a 2-star type of an item. And like I said before, collapse-prone irregularities, so like vertical discontinuities, that's a biggie. That would be a 2-star type item. So going back to the example, let's say we have a building that does not, the soft story tier 1 check is non-compliant. So that means for that particular building, the maximum safety subrating we can get is a 1-star. Because not every single item in this in this list here is compliant. But now let's say we did a tier 2 analysis and that particular soft story was shown that is okay. It is now compliant through tier 2 analysis. Now you could get up to 2 stars. In our case, example building 1, it was a life safe, so we know that we've satisfied all the items in the 3-star and 4-star. And like I said, the structural safety sub-rating doesn't really differentiate between the 4 and 3 stars, so it's kind of a bookkeeping exercise here is why the 4 and 3 star are the same. And for 5-star, for a steel moment frame, again, we're really, even though the table 2.1 shows a 5-star rating, you can't get 5 stars because it's a flexible system. So you have to remember that the maximum safety sub-rating is limited to 4-star for the flexible buildings. So now we've moved from section 2.1 to 2.2. There's another checklist. Now we're going now from the tables in 2.1 to table 2.2 as well. Again, the checklist is identical for 3-star and 4-star. And there's a little caveat here that if you'll see in table 2.2, I'll go to that shortly. The liquefaction is not indicated to be necessary for 2-star. However, if you are at a building site where lateral spreading could potentially, due to liquefaction, could lead to a structural collapse, then you need to modify table 2.2 to include a 2-star for the liquefaction item. So here, again, here's the ASC 31 checklists. In this case, we had a single, for the example building number 1, we had a single non-compliant for overturning, and we'll see what that implication. Okay, so here's table 2.2. This gives you all what's required in order to get the different types of ratings. So let's jump into the 2-star rating again. For example, if you were out on a site where you didn't, where lateral spreading due to liquefaction would lead to a global collapse potentially. If we don't have that item being compliant, then this would be a 1-star rating. If we were to do further analysis and say that it is actually compliant, then now we could get a 2-star rating as long as slope failure was compliant, surface fault rupture is compliant, and pull foundation throw was compliant. So now for our case, we were hoping, we're checking to see whether or not we had all the compliant items to be a 3 or a 4-star. Unfortunately, overturning was a non-compliant in our exempting building 1, which means our maximum rating now is 2 stars. Because every other item is compliant other than the overturning. So we no longer satisfy all the compliant items for 3-star. We bump down to 2-star. Again, 5-star, if you satisfy all those, if everything is compliant, or it may be that in your particular building, let's say you don't have deep foundations, that would be it's not applicable. If it's not applicable or it's compliant, those both are kind of result in the same rating where it would not decrease your rating. All right, so now we've gone 2 out of the 3. We move on to the non-structural safety subrating. We're moving now into section 2.3. Again, there are tables, there are new tables, the table 2.3, which lists all the non-structural items in the ASC 31 checklists. What's a little bit unique for the non-structural safety subrating, if you can use your engineering judgment and say that if these items are located in locations in the building that would not cause severe injury or death, widespread injury or death, you could exclude those particular items from this non-structural safety subrating. I just want to reiterate, this is only for the non-structural safety subrating. You can't do this for the recovery or the repair cost subrating. So again, here, this is a typical, this is the ASC 31 checklist. For example, building 1, our stair details are non-compliant. So we had a flexible building, the stairs are connected to the diaphragm or to the concrete slab with short abutment anchors. So just a tier 1 analysis says that this is non-compliant. And you can see there's quite a bit of non-structural items that we need to go through. And in our example building, we said everything other than the stairs was compliant. So this is the Building Ratings Committee's kind of amalgamated table that pulled all those non-structural checklist items into kind of a more condensed table here, which kind of helps visualize all the information. So now again, we'll kind of go through what does it mean to have a 1-star non-structural safety subrating. In this case, let's say you have your flexible coupling item is non-compliant. You now have a 1-star building because you needed both the flexible coupling and the gas cylinders to be compliant to get at least a 2-star rating. And again, if you were to do tier 2, you could say, well, maybe the displacements are big enough that the flexible coupling isn't required. Generally you would put flexible couplings there. If it's not compliant, you would probably go in and fix that anyway. But that would now allow you to get up to 2 stars. Okay, on to the 3-star. You can see, we still need the 2-star requirements. That's why those are still highlighted. And now we have a bunch of new requirements to get at least a 3-star. So for our building, we were saying that the stair details were non-compliant. So unfortunately, we're so close to getting a 3-star non-structural safety subrating, but because of the 1 stair detail item, the maximum rating we can get is 2 stars. To 4 stars, you can see each time we go up a level, more and more items are required to be compliant in order to get that particular subrating. And again, 5 stars, where we keep growing and growing. So now to kind of step back, we went through, for the example building number 1, because it was a life-safe flexible building, we got a 4-star because we had overstretch in our foundations. The maximum geologic foundation rating we could get was 2-star, and since we had non-compliant stair details, the maximum rating we got was 2 stars for non-structural. So now we compare all those, and we see that the least number of stars out of all those sub-ratings was a 2-star. It was a tie between geologic and non-structural. That was our limit. And there's a difference kind of between the USRC's kind of, I think, slant on, we're looking more at new design whereas the existing buildings committee was more focused on obviously existing buildings. So if you read through the EPRS and that ASC 31 translation, you'll see a couple tips that really kind of key you in if you're doing evaluations of many buildings. You see that you could have a single non-compliance could very quickly determine your safety rating. So if you're looking at a big portfolio of buildings and you had a couple buildings that had, like what we said, stair details were non-compliant, if you're not looking to increase that rating and you're just looking at the very basic rating, you can stop right there. Just look at that non-structural checklist item. You have a single non-compliant, and you don't have to kind of pour through the rest of the checklists. So that's more of a time-saving thing. But for a USRC rating, you do need to go through that whole process. Again, to kind of reiterate what Doug had gone through, just to compare the two different ratings, has more to do with kind of it's just the terminology. It's not so definite. To say that there are no deaths within the structure, it's very definitive. It's a little bit softer to say that the loss of life is unlikely. It kind of goes along with where the public says is that we have earthquake-proof buildings. We know that's not really true. They're earthquake resilient. The earthquake-proof doesn't really exist. All right. So now we finished the safety rating. We're going to move on to the repair cost rating here. So I think Doug already went through all this information, so I'll kind of just place in the back for you to kind of refocus on what does it mean for the repair cost. The 5-star is incredible if you can demonstrate that you have less than 5% damage for replacement value. Even the typical insurance deductible of that 10%, it's pretty tough to get to. 20%, that's usually where that PML number kind of comes in. And then repairable damage, that was kind of just a line drawn, kind of in the sand. I don't know if there was really any definite reasoning for 20 versus 50 or 60. I don't recall off the top of my head for that. So for the repair cost, there's 2 sub-ratings, unlike in the safety where we had the 3. We're combining the structural and non-structural. We'll jump into the geologic site hazard sub-rating. You would go into the Appendix C, Section 3.1. And this is, it's a little bit simpler. If any of the items below from Table 2.2 are non-compliant, then your sub-rating is a 1-star. If you have compliant for those 3 items, then it's a 5-star. The structural, non-structural, this was another considerable effort by the committee to actually generate Table 3.2. It's a very nice, concise table. I'll go into exactly how we developed that table shortly. Again, so for the structural, non-structural, this is in Section 3.2. All items must be evaluated, unlike in these the safety sub-rating, where if you could use your engineering judgment to say that maybe some non-compliant, non-structural items in a boiler room don't really dictate the overall building performance. Here, in repair cost or in damage sub-rating, that's a big part of those ratings. So it is important to include all non-structural items. What was interesting from some of our findings was that for a 5-star safety rating, you could get a max of 3 stars for non-wood type buildings, and for wood type buildings, even though you have a 5-star safety rating, we were finding that the max you get would be like a 4-star repair cost sub rating. The committee used ST Risk. They were very nice to allow us to use the software to kind of do a trial run. We picked a site in San Francisco. We figured that was kind of just a good location to start with. What we did was we ran through every single seismic force resisting system listed in ASC 31, and we modified the inputs. We had a map, what ASC 31 had for each of the structural checklist items, a map as to what ST Risk had. So that that was a process to go through, and then also now to go into the ST Risk and say, okay, now if I have a 2-star safety rating, which items in ST risk would be true or false based on that minimal safety rating, and then do the same thing for the 3-star safety rating. And as background, the ST risk is also based on FEMA 310. So that was why we had to kind of do a translation between ASC 31 and then FEMA 310. Okay. So this is the effort of a committee where, so for a 2-star safety rating, this was the range that we saw in the repair cost. So I'm going to go into, this is for all the different buildings. Let's look at like a steel moment frame building, kind of like our example that we had. So for the 2-star minimum safety, I've kind of modified table 2.1 for if all those items are compliant, along with the geologic site hazards and foundations being compliant, we're kind of at the lower end of the SEL, the scenario estimated loss. Let's say that's about 38%. And that would be assuming that all of our non-structural items are compliant. So now we'll look at, what effect do we have with non-structural items either being compliant or non-compliant. So if we start out with assuming that our non-structural is a 2-star, for a 2-star safety subrating, these were the only compliant items we needed in the non-structural safety sublist. So that, this kind of gives you an indication. This would be the maximum SEL that we would kind of see in an S1 based on ST risk. So that gave us an upper bound. And we said, okay, now what if we had a 5-star safety non-structural safety subrating? How much better of an SEL do we get for the steel building? So you see, for a minimal 2-star building, we went from, let's say, 48 to, let's say, 38%. And we went, this slide gives you the different bands, just kind of indicating, for a 2-star safety building, using ST risk and using ASC 31, which was never really developed to be able to generate repair costs. It's going to be very conservative. And that's what you're seeing here in this plot, is that the repair costs are very, pretty large for many of these buildings. And that, it'd be very difficult to show for the S1 that you really have a 2-star rating for repair cost if we were to use the ST risk in this very conservative mapping. So you can kind of see here that, I had 3, 4, 5 stars. You have that option, but if you're using this conservative translation, you really are kind of limited to having a 1 or 2 star if you only have a 2-star safety subrating. But you do see a little band there. The wood frame buildings, the wood type buildings, are generally lower than the rest of the buildings. So in the table 3.2, you'll see that's why we kind of differentiated between W1, W1A, and W2 from the remaining building. And this is the kind of same procedure that we did for the 3-star safety rating. You'll see that all the blue bar has kind of moved down. Now the orange bar is just to let you know that you're looking at a different plot. But again, we're really looking at, kind of a max of 1, 2-star. Some of the steel buildings and the wood frame buildings are doing a little bit better now. So now you might be able to show that you can get a 3-star rating for the repair cost with a minimum 3-star safety rating. This is how do we map the safety ratings from the ASC 31 into a repair cost. So for if you have a 5 or 4-star rating, it jumps down to 3 stars. This is the same information from table 3.2, but just in a different format. Maybe to help you kind of see what's the max rating you'll get. We had a 3-star that drops down to 2 stars for repair cost. 2 and 1 star both drop down to 1 star. There is a error here. The repairable 2-star and 1-star should be 40% as opposed to 50%. And now for the wood type buildings, you'll see you get a little bit better, right? If you have a 5 or 4-star safety rating, you can get a 4-star repair cost. 3-star maps to 3, 2 to 2, and 1 to 1. So you get a little bit better. Wood frames are not as conservative. We used our judgment to be a little bit more lenient on the wood frame buildings. All right, so getting back to our example 1, we didn't have any of the geologic site, or all our items were compliant for the geologic site hazards. We got a rating of 5 stars. Unfortunately, we had our safety rating was 2 stars, so we got bumped down to 1 star for the non-structural rating. So overall, our repair cost is 1 star. That's kind of shocking. We did all this work in the ASC 31 to fill out all those checklists, and we're down at a 1 star. Fortunately, the USRC methodology allows us to modify that. I'll talk about that after the slide. Here's just another comparison between the USRC rating and the GPRS rating. Again, just kind of showing the kind of the softer short terms between the two, and then not kind of dictating what the committee had thought were kind of standard deductible limits, or what the operating budget would be for a typical owner. You see how conservative ASC 31, the mapping of the ASC 31 safety ratings into a repair cost was. You're kind of, for most buildings, you're going to be down to 2 star or 1 star. For USRC, a certified rating professional, the CRP, is allowed to use any of the following methods to generate a more specific damage rating, as opposed to using this very conservative, very broad brush rating that we did in the existing building subrating committee. So you can use ST risk specifically for your building. You can use hazardous or use the very advanced FEMA P58 to get a better rating. All right, so now moving on to the last dimension, recovery. So again, we have 3 subratings. We have the geologic, structural, non-structural, and then we take the minimum of those 3 in order to come up with our overall recovery rating. So kind of step 1, looking in, we'll go to section 4.1, and again in Appendix D, we'll look at the checklist. You see it's similar to what we saw in 3.1. We only have the 3 items. So in our case, we were compliant for all 3, so we can get a 5-star rating for the geologic foundation hazard. If we had a non-compliant for any of those items, again, we would be down to 1 star. Okay, so now for the subrating, we'll go to section 4.2. So for the safety subrating, we had a direct mapping for a 5-star goes to 5 stars, 4 and 3 stars of safety subrating goes to 3 stars. The 2 stars and 1 star for the safety subrating go to 1 star. So I just want to, I'll be totally honest, it's very confusing between having a safety rating and then there's a safety subrating. So I've tried to on all these slides, to indicate exactly what it is that you use in order to translate from one to the other. So in this case, we are using just the safety subrating in order to translate into the safety structural recovery subrating. Moving on to the non-structural recovery subrating, we move on to section 4.3. This has a different table. It's table 4.3.1. This table is not, the non-structural items are shifted around in this table, so you can't use the table that was listed in the repair cost for the non-structural items. Again, all non-structural items must be evaluated. This translation was based on the work by David Bonowitz. I did a great job. And there is a modification based on how extensive certain non-compliant items are, whether or not it's they would affect public use, and whether or not you have specialized contents within your structure. So this is the first time we're kind of really seeing that there's any type of building-specific content will affect a rating. So again, this is the kind of amalgamated table that David developed, pulling all the non-structural checklist items into a single table to kind of make it easier to visualize and see. So again, let's step through what does it mean, how do you get a 1-star non-structural recovery subrating. In this case, if the flexible coupling is non-compliant, the max rating we get now is a 1-star. We can't get anything higher than that. If we fix that, go in, and fix the flexible couplings, now we can get up to a maximum of 2 stars. Kind of like what we saw before. Each time we go up the ratings, now we're trying to demonstrate that we have a 3-star subrating. we have to satisfy a lot more non-structural checklist items, and just continues to grow from there. In our case, our stair details were non-compliant, so building example number 1, which means that we can't get a 3-star sub-rating because we have a single non-compliant item. The maximum we can get now is 2 stars. Again, 4 stars we're building, you see, the number of items that need to be compliant just grows and grows. 5-star, you need everything to be compliant. And now I'm going to give a little kind of sub-example about how do we do the recovery adjustment. So for our, let's go say for an example building, you have an initial, you have all the items in the 2-star and the 3-star are compliant. Now to determine whether or not you have a recovery adjustment, you would take that 3-star and you go one level above that, and then you go 2 levels above that. So now we want to look at both the 4-star column and the 5-star column. And we would look to see whether or not our specific building, if any of those items, we know they're non-compliant, but because they're non-compliant, is it pervasive? Would it affect the public use? So let's say for 30-story steel moment frame building, on a corner lot, we would say that based on the size, we're looking at the cladding. If those are non-compliant, that would potentially knock us down 1 star. And then also it's on our public right of way. So if we also have cladding that may fall off the building, that would pull us down another star. So now we thought we started out with 3-star, but because of these recovery adjustments, now we've revised it down to be a 2-star. So for our specific example building, we had a 5-star geologic sub-rating, 3-star structural, 2-star non-structural. So our overall rating again was limited to 2 stars. Again, just a comparison between the USRC and the GPRS ratings. Again, the USRC kind of gives you more of a range as opposed to kind of very hard, or kind of more of like a stepwise function that the GPRS has. So now, okay, we did a great job, went through all the ASC 31 checklists. We went through the GPRS, the ASC 31 translation. Now what we can do is come up with our overall rating. So we take all the sub-ratings we generated for the safety, all the sub-ratings we generated for the repair cost, all the ratings we generated for recovery, and we kind of pull them all into a summary table here. And so for the safety, we had the minimum out of the 3 was 2-star, repair cost was 1-star, recovery was 2-star. So our overall reported rating would be a 2-star safety, 1-star repair cost, 2-star recovery. So that was all the ASC 31 translation. So now how do we then map this to the USRC rating? Unfortunately, we'll look at the table that was listed at the very beginning of Appendix D, and a 2-star CEONC rating matched to 2 stars USRC, 1-star and the repair cost matches to a 1-star in damage, and a 2-star recovery matches to 2-star recovery of the USRC. And again, I just want to reiterate that the USRC methodology does allow you to use either ST risk, HAZUS, or FEMA P58 in order to increase your repair cost or the damage dimension. Okay, now we'll go to a much shorter building example, a little bit different. We have pre-Northridge connections. It's a little bit taller, 36 stories. Again, non-benchmark. Here we have a couple structural items that are non-compliant. We have moment-resistant connections, which are non-compliant per Tier 1, panel zones non-compliant per Tier 1, and also the strong column weak beam. That's pretty typical in a pre-Northridge building. We do use ST risk in this case to refine the damage rating, and we're using based on we have a very tall building, so we're going to have size adjustments to our recovery rating. So here's our checklist. I've only marked the kind of simplified it just to not kind of make it difficult to see the Tier 1 items that were previously non-conforming. We did the Tier 2 analysis to show that they're conforming. So this is just kind of a way to indicate that they were previously non-conforming and now they are conforming, just kind of for bookkeeping purposes in the checklist. And so this building sub rating would end up being 4-star for safety overall, 3-star for repair costs, because we did a ST risk. We were able to kind of circumvent the conservative AST31 translation, and then repair costs were still down at 2-star, or recovery were still down at 2 stars. Again, that was because of the adjustments due to the building size and it being on a corner lot. Both of those items knocked down a recovery rating. So for this building, again, 4-star translates to 4-star for safety, 3-star translates to 3-star damage, and recovery translates to 2-star between the two. Going back to the USRC implementation manual, kind of stepping back out of the EPRS, the Appendix C, Chapter 4, lists some cases where you may have an elevated review. So in any of the cases where you have a 4-star, 5-star in any dimension, that will trigger an elevated review. So for our example, Building 2, we had a 4-star safety rating, so that would actually trigger a 4-star, or excuse me, an elevated review. If you have a risk category 3 or 4 type building, and then if you have any type of vulnerable buildings, in our case we had we would have been in an elevated review anyway because we had a pre-Northridge type building and those connections hadn't been retrofitted previously. Or if you have a non-common building type, you're kind of outside the bounds of, let's say, an ASC 31 type evaluation, you'll get an elevated review. Or you may get an elevated review. So now we'll go into some of the SB3 software. I know Kurt in the P58 modules has kind of gotten into, I think, a good in-depth review of the software. I'm just going to show a couple screenshots to show you what's available to be able to enter this information and kind of automate the translation as opposed to doing it all by hand, which is what the CON GPRS AST31 translation requires you to do. And so, I just threw an example building in the East Bay, San Francisco, moment frame building, so kind of sticking to that. We had 12 stories, commercial building, type 2 risk category. And up at the top, you can just click on the AST31 tab, and that will pull up this checklist. And so we'll pull up our typical building type, an S1 building, what our performance level was, life safe, and we were in a high seismic zone. And then you can click on the little blue button, which just says Gather Checklists, and that will automatically gather the checklists that you need in order to fill out. Unfortunately, they don't come pre-filled out for you. That would be amazing, but that's your job. You get to fill out all these items. In our case, let's say, so for example, 2, we were eligible because we did our site visit, we did all the investigation. We're not benchmarked, right? So you start to see that you're filling out all these little checklist items, which are essentially the AST31 checklist, just in button format. Moving on down to the basics, the basic list, and just to kind of show you that everything we had shown before is listed here. What I find to be helpful is to have the table 2.1 maybe next to you while you're filling this out, so you can kind of see, if you have a single, what's the implication of not having an item compliant or non-compliant. It's not, for me, just visually, it's not necessarily that clear in just the SBC software the way it is written just right now. If you, let's say for the load path, if it was non-compliant, it says 2 stars there. What does it mean by it being non-compliant? Whereas if you go back to table 2.1, you see that, the max rating you can get is now a 1 star. So kind of a summary now is that the AST31 is very conservative by design. It's really meant for a broad portfolio of buildings. Anything and everything that could ever be possibly wrong in your building is listed in those checklists, in the checklists. And a single item could ding your rating from, let's say, a 4-star to a 1-star. We saw that happening. AST31 does allow engineering judgment it's within the limits of the methodology. I think Appendix B1 and AST31 provides that in the examples. And overall, you need to, wherever you're using your engineering judgment, you need to document that for the USRC review through the guidelines. So again, I know we put this up a few times, acknowledging all the committee members that were involved in developing the EPRS. It was definitely a group effort. I really appreciate everybody's work. It was an incredible opportunity to have it, to be able to work on a project that I think is really going to have some really good positive change in our interaction with the public regarding not just seismic safety. That's what I talked about here, but the USRC is really looking at all hazards. So I think it's an incredible time for us. I think I was very fortunate to be able to have the opportunity to have worked on to be at work in the committee on this. These are all the references that all this information pulled from.